Hey, here I have the icosahedron. Um, I have it divided into 60 sectors, I guess. Um, and there, it's this weird shaped quadrilateral. Um, each icovertex has a color assigned to it, um, and the vertices on opposite sides have the same color, and then the color CN's not assigned. Um, okay, now we're looking at the dual graph. So I'll add a vertex, um, and you can see it gets copied onto each of the 60 different sectors. Um, and when I move it around, uh, the copy, all the copies are in the same relative place on their sector. And not only that, but the color is permuted um, for each sector. So the way that works is, um, okay, so I'm working in this sector here, and then let's figure out how the colors map onto this sector. Well, the way you get from this sector to this sector is you can sort of think about like rotating around this point. And when you do that, then um, yeah, this position gets mapped to this position, so that makes sense. And then this red icovertex gets mapped to this blue one, so that means red colors in here become blue colors in here. So let's change the color of this guy to be, say, blue instead. Now, for this sector, the blue icovertex is here, so then when we rotate this guy, when we map this sector onto this one, that blue gets rotated to the yellow. So this means that in here, blue gets mapped to yellow into here. And then same here, if you pick yellow, then yellow's up here. If we swing this around 120 degrees, then yellow gets pushed to red. And that's what we see in here is yellow gets mapped to red. And then I guess let's try green here. So for this sector, the green icovertex is down here, and when we rotate to get to this sector, where does it go? It goes, oh, sort of out of sight. It goes here to the purple one. Yeah, so green in here maps to purple here. Okay, so that's how the colors map. And now we're interested in coming up with a hex grid that covers this whole triangle. So let's so I'll randomly put down a hex pattern here. Okay, so that's the bottom layer of the hex pattern, and then I'll do the next row. So I'll just index 3 into here. Start with purple, and then in the same order. Okay, so that's the next row of our hex pattern. Okay, so in order, and these hex patterns have to merge between sectors, but if we look here to the right of red, we have blue, but here to the right of red, we have green. And then to the right of blue, we have yellow, and that doesn't match up here. That doesn't match up here, so we have an inconsistency here. So you can't just use any permutation of colors to make the hex pattern. And let's see, I have a program here that'll print out the ones that are consistent for an icoface. And yeah, there's a bunch of different ones that work. So let's try one. Okay, so this one goes red, blue, 3, 2, 4. I have the yeah, so it's actually the same thing, but the purple and yellow are flipped. So there's yellow. Okay, so that seems to work. And now if we look here, to the right of red is blue, so that's correct. To the right of blue is purple, blue then purple, purple then yellow, purple, yellow. Okay, so this pattern works, and we can extend this hex grid and sort of merge these together and get like one seamless thing, one seamless honeycomb pattern. But now we'll run into another problem because this pattern and this pattern are pretty different. So if we look here, we have red, blue. It's the same here so far. Red, blue, blue, then purple. Yeah, that's way off. Then purple, then yellow, yellow, then green. Yeah, yellow, yellow, green, orange. Those three in a row, but there's too many. The difference is too much between those two, so you won't be able to really stitch those together. Okay, now let's pick another pattern. But like I can run the program again, but then require that the patterns match up except for a single swap. And now there's really only two unique solutions, so let me input that guy. So 0, 2, 6, 3, 5, 1, 4. Okay, so the next row starts with purple, orange, blue, green, red, yellow. Okay, so now again we can verify that the hex patterns match here, and furthermore we can see that this pattern, the order of colors here, matches the order of colors here, except for, oh, wait a minute, I inputted, I have two oranges here, 0, 2, 6. Okay, that should be right. So yeah, so let's see. So here we have red, yellow, cyan, purple, orange, blue, green, and then here we have the same order except cyan and purple are swapped. Yeah, so this is like basically one of only two hex patterns that work up to yeah, you can sort of cycle them, so you can start the hex pattern on any one of these 7 colors. So yeah, if we ignore the cyclic permutation, yeah, just cycling the permutation, there's only 2 unique ones, and one of them turns out, I think, not to work because there's some same color vertex, like once you get close to the center here, the same color vertex is sort of too close together,